All right, kiddos, so this is going to be our first Unit 2 video. We're going to start getting into triangulation, beginning with triangular properties. Then we're going to get into, certain applications of triangulation, and then, of course, we're going to get into trigonometry. But first, let's start just with some basics about triangles in general. So here's our EQs for today. What is a triangle? What is true about a triangle's interior and exterior angles? What types of triangles are there based on side lengths and angles? What are the key characteristics of different types of triangles? And what is the triangle inequality theorem? And what does it mean exactly? So let's start by answering EQ1. What is a triangle? Okay, so a triangle is a polygon. It's a fancy way of saying a two-dimensional closed figure with 3 vertices and 3 linear sides. So, more or less, there's a triangle. Okay, it has 3 vertices, A, we'll call this guy B, and this guy we'll call him C. And it has 3 linear sides, A, B, and C. And you'll notice how I'm labeling C opposite of C, B opposite of B, A opposite of A. There's a reason for that. When we get into trig, you'll see why. Okay, but from now on, when we draw triangles, we need to try and label with the same letter opposite of one another. So side A is opposite of vertex A. Side B is opposite of vertex B, and so on. Okay, and like I said, we'll get into why we're going to do that when we get into trig. Trust me, it's really helpful. Anyway, interior angle sum is 180. So our interior angles, A, B, and C, right? Our interior angles sum on any triangle will be 180 degrees. And our exterior angle sum. Well, what are exterior angles? Well, let's kind of elaborate on what that means. So see this side C right here? What if I continued it on out past vertex B? Okay, and this vertex here created here, or this angle, I should say, created here at vertex B on the outside, hence exterior, right? Let's call this D. Okay, so that would be exterior angle D. And that's what I mean by an exterior angle. I mean an outside angle. And same idea, I've got 3 of them. So here's our other vertex, obviously, vertex C, right? And if I continued side A out past vertex C, and let's call this vertex E, or angle E, rather. Okay, so it's outside of the figure. The exterior angles are outside of the figure. Okay, so there's one more, and that would be our exterior angle F. And if it continues past vertex A, so F would be this guy here. Okay, and you can see that the exterior angles are supplementary to the interior ones. Okay, so just an important little tidbit there. And what do I mean by supplementary? So for example, A and its exterior angle F, they are supplementary, right? Meaning that A plus F equals 180. Okay, so always keep that in mind. That's something we learned a while ago. Anywho, so we're saying that exterior angle sum is 360 degrees. So that means D plus E plus F is equal to 360 degrees. So our interior angles add to 180 and our exterior angles add to 360. Okay, so let's keep going. So types of triangles, and I believe, what EQ is this? we are on EQ3 now. So types of triangles. Based on our sides, we have different types of triangles, and based on our based on our angles. Okay, so based on our sides, let's start there, why not? Based on our sides, we have equilateral triangles. Okay, so that means if I've got an equilateral triangle, that means that all three sides are the same. They're the same length, right? So three sides congruent. Okay, that's how you know you have an equilateral triangle based on its sides. Okay, what about an isosceles triangle? Okay, so an isosceles triangle is like this. It has two sides congruent, right? And another example, I mean, it wouldn't have to be skinny like that, just as long as two sides are congruent. So let's say A, B, and A equals B. Well, this will also be isosceles. Okay, and then you've also got your scalene triangles. And scalene triangles, they're the ugly triangles of the bunch. Let's see if I can draw it decently, even though they're supposed to be a little ugly. But why are they the ugliest ones of the bunch? Well, because none of the sides are congruent. Okay, so A does not equal B, B does not equal C, A does not equal C, and so on. Okay, no sides congruent, right? Okay, so we can also classify triangles based on their angles. Okay, so besides classifying them based on their side lengths, which is what I just did, we can also classify them based on their vertices, their interior angles. Okay, so let's start with equiangular. And here, let me try to color match a little bit. So equiangular is going to look like this, and we're going to notice something about equiangular triangles. But vertex A, B, and C on an equiangular triangle would all be congruent. Okay? All three vertices, or all three interior angles, are congruent. Okay, so now let's look at, I'm running out of colors here, a right triangle, and we all have an idea of what this guy's going to look like. Okay, so what's true about a right triangle is that you'll have a 90-degree vertex. Any triangle that has a 90-degree vertex is going to be a right triangle. Okay, what about acute triangles? Okay, acute triangles, oops, that was a bad example. Running out of room here. Well, I guess I'm really not. But an acute triangle, so you have vertex A, B, and C, right? A, B, and C are all less than 90. Okay, they're all acute, right? They're all acute angles. Okay, so if you have a triangle where, and this is still a bad example, I just can't draw it today. If you have a triangle where all of your, all three vertices are acute, right? Then you have an acute triangle. Okay, and let me draw a better example, because right there, based on that crappy picture I drew, it looks like C is greater than 90. Here, we'll just do this. We'll do that. So there, all three, so let's call this A, B, and C, all three are less than 90. Okay, and another example would kind of be like, this one right here could be acute, or the one right here in orange, if I just made this slightly less than what it was, right? So if I called this A, B, and C, again, all three of these would be less than 90, meaning they are acute triangles. Okay, so pretty simple so far. And our last one, we have obtuse triangles, and let's see what color I want to use for that one. So obtuse triangles, I mean, you can kind of guess from the name. Obtuse triangles have one angle greater than 90. So if I call this angle C, C is greater than 90. And the other two would be acute, which doesn't really matter, but you have one obtuse vertex, meaning greater than 90. Okay, so that's your four classifications based on angles, right? So now we're going to come here and work a little bit on drawing some triangles. Okay, and I'm not going to go too much into detail or into precision here on this video, but in the actual class lesson, I'm going to go into a lot of detail, and I'm going to be using a visualizer, kind of like trying to think of what they're called, like a desktop cam or something, where you guys can see me actually using the protractor. But for some reason, every time I try to record with it here, it doesn't like it. So looking at number one, and I'm just going to go through a few of these. So looking at number one, I'll probably only go through number 1 and 2. But number 1, let's say you had an obtuse scalene triangle. Okay, so obtuse means, what does obtuse mean? You have a vertex that's greater than 90 degrees. And a scalene, if it's scalene, well, what does that mean? That means all sides are different lengths. Okay, so all I'm going to have to do is just make sure one of my angles is greater than 90. So this guy here is 5 centimeters. This guy here that I drew was right at 9 centimeters. And this guy, let's see, is going to be, I'm going to need a ruler, right at 13 centimeters. Okay, and this angle here, eyeball it a little bit, is right at about 140. Right, this guy here is right at 26 degrees. And this guy is right at, we'll call that, oh man, I'm blind. Call that 14 degrees. Okay, so this would be a scalene obtuse triangle. I've got my obtuse vertex here, and all three side lengths, obviously, are different lengths. Okay, so I'll do one more example. I'll go ahead and do number 2 now. And again, like I said, in class or in tutoring, I'll be able to help you with it as far as like how to draw this stuff. If you're having trouble, I'll be able to give you a much better visual. You can kind of get an idea of what I'm doing based on, you know, this video, but like I said, for some stupid reason, my little desk cam does not like being used with my recorder, my video recorder. So an acute scalene triangle. So again, we're drawing a scalene triangle. Okay, so this first side I drew was right at 10 centimeters. And this other guy I drew is right at Well, I went over a little bit. We'll call it 8.1 centimeters. Okay, and I want it to be scalene, so all three sides have to be different. Same thing for what I did on number one, but this time I want it to be an acute triangle. Okay, and based on what I've got drawn so far, I'm going to have to make this other side longer. Yeah, I'm going to have to make this other side longer. So 8.1 centimeters is not going to work. So I'm going to need to make this guy a little bit longer, so that way my other vertex is smaller than 90 degrees. Okay, so I'll make it, let's see, I'll make it about that much longer. Okay, so why not? So this guy is now, let's see, this guy is now 11.7. And sometimes you just have to play with these. So I think if I line it up here instead, that'll give me, yeah, it won't be isosceles because part of it is kind of jacked up. So I'm going to cut that off. And let's get the actual measurement of this guy. So this guy's at about 10.2. Oops, still erasing. 10.2 centimeters. This guy here is about 5 centimeters. And let's get our angle measurements. So this guy is right at 79 degrees. This guy here is at about 29. And this guy here, let's see, this guy here is at about 71. 71, we'll call it 72. It was closer to 72, I think. Okay, so all three angles are acute, right? So if I call this A, B, C, A, B, and C are all less than 90 degrees. Okay, and then all three of my side lengths, so side A, side C, and side B, all three of my side lengths are not equal, or unequal, or not congruent, okay, which makes it a scalene. Right, so that was a little crash course on that. So now real quick, let's talk about what kind of triangles are possible. And in order to explore that, we will always come back to the triangle inequality theorem. So in class, I'm going to have you figure out the triangle inequality theorem on your own. But in this video, it's going to be kind of difficult to do that. So looking at this triangle, what do we notice? Well, basically, if you combined A plus B, right, side A plus side B, you can obviously and plainly see that side A plus side B would be greater than side C on its own. Okay, so to give you a numerical example, let's say that side A was, I don't know, let's say it's 2, and side B was 6, right? That would mean that 2 plus 6 would have to be greater than whatever side C is, right? And if we actually measure, so if I actually take a ruler to this, so let's not use arbitrary numbers. Let's get some actual measurements. You can tell by looking at this, just common sense, just axiomatically speaking. Let's get some real measurements here. So this guy is about 5.2 centimeters. And B is right at, it's pretty dang close to, we'll call it 10.9. Okay, and side C is about 13.5. 13.5 centimeters, right? So what's that mean? Well, basically, it is impossible. It's impossible to have a triangle where one side is larger than the other two combined. Okay? This is not possible. Okay, and why is it not possible? Well, I challenge you to actually play around with some triangles and try this. Okay, this right here is not possible. This is your triangle inequality theorem. Okay, so basically, if I have, can't draw right now, if I have a triangle with sides A, B, and C, where C is the longest side, then A plus B must be greater than C. And we wouldn't say greater than or equal to. And again, I challenge you to try and figure that out on your own, why that is. Okay, I challenge you to figure out why we wouldn't say A plus B is greater than or equal to C. Okay, and I may actually make a little extra credit project out of this. Haven't made up my mind yet. But this is your triangle inequality theorem, and it is true beyond a doubt. True beyond a doubt. All right, so here's our EQs. What's a triangle? Answered that. It's a polygon with three vertices and 3 linear sides. Its interior angles add to 180 degrees. Its exterior angles add to 360 degrees. And we'll notice something about other polygons in that respect later on. What types of triangles are there based on the side lengths? You've got equilateral, you've got scalene and isosceles. What about based on the interior angles or its vertices? You have got equiangular, acute, obtuse, and right triangles. Okay, what are the key characteristics of the different types of triangles? We went over all of that. I'm not going to repeat all of that and draw it all again. And number 5, what is the triangle inequality theorem and what does it mean? Okay, so the triangle inequality theorem is simply that no one side of a triangle is greater than the other two combined, basically. That's basically what it means. No one side of a triangle is greater in length. Go ahead and elaborate. Than the other two combined. All right, kiddos, that's it for this video. Obviously, if you have any questions, let me know or come to tutoring. And yeah, have a great day. Goodbye.